This paper is about two things. It's about a new method to detect and quantify emotions, and it's about some important results that we found using these methods on the emotions of disrupted knowledge workers. This work builds upon a rich literature that appeared in recent years regarding the display of emotions and how this could affect co-workers, especially in open office spaces. It also builds on work with regard to multitasking, especially email interruptions, which are ubiquitous in the modern office, and how multitasking and email interruptions are associated with stress. General architecture of this research. So we had a study design to induce some interruption effects, and then we needed a method to quantify the displayed emotions produced. So let's see first of all the study design that we built. We had 26 participants. We split the participants into two groups. One group that was interrupted only once and had to answer all 8 emails in one go. And the other group, the so-called continual group, which had to answer emails as they were arriving, and they were arriving every few minutes. Now, methods, and that boils down to the method that we use to quantify emotions. Actually, first we used a convolutional neural network to go from facial expressions to basic emotions as probabilistic vectors. So at each point in time, this CNN was returning a vector with the 7 basic emotions, one of which is the neutral emotion. The summation of these probabilities, of course, was adding to 1. So we realized at some point that these probabilities should not be used as they are given because they overestimate emotional display. The reason for this is that the neural network actually arrives at these values. In many cases, these values are not overwhelming towards a single emotional component, but they are split sometimes between 2 or even 3 components. And they manifest an uncertainty about what emotion is really on the participant's face. And this uncertainty typically stems from the fact that hints from more than one emotions are present at the same time. So we basically, taking this into account, expanded using the joint probabilities law this vector into a matrix. We took basically all possible combinations among pairs so that we give a more accurate probabilistic picture of what the neural network was communicating to us. And thus we formed what we call the co-occurrence matrix. In this matrix, which is symmetric, therefore it can be folded into just the upper triangle. And in this upper triangle, the diagonal shows the basic emotions, but whose probabilities have been adjusted. Why they have been adjusted? Because they gave a little bit of their strength to the elements in the upper triangle of this matrix, which are basically the mixed emotions. So, this is a fundamental departure from traditional approaches which do not take into account this consideration and give all the probabilities as they are to the raw basic emotional vectors. Therefore, they are overestimated. So using this method, not only we scaled back the probabilities of the basic emotions to their true values, but we also thus released a picture of likely mixed emotions that co-occur at the face at the same time, which added another insightful dimension into the results. And speaking of results, here's what we have. I remind you, we have two groups: the B group, the batch group interruption, and C group, the continual group interruption. In this study, all close to an hour of recording for each participant, we gathered 780,000 facial frames for the 26 participants, and for each of these frames we got from the neural network an initial probability vector, which we analyzed further, constructing for each one of those the co-occurrence matrix, thus reducing or adjusting rather the basic emotion probabilities and bringing into the picture the probabilities of the mixed emotions. And therefore we ended up with 780,000 matrices. These matrices were summed up per group, and you see here the results. We had the summative group B matrix and the summative group C matrix. You already see, for example, in the B, the neutral basic emotion is very strong. In the C, you see, in contradistinction, the sad emotion is very strong, something that will actually pop up a little later in the models. When we move from the basic emotions to the mixed emotions, in group C, we see that sadness and fear is one of the notable mixed emotions. In the batch group, actually neutrality with a little bit of sadness, but not as strong as in the other case. Just to quantify all these things, we ran a linear model where the response variable is basically first the basic emotions, those things that you see on the diagonal of the co-occurrence matrix, and the predictors is the emotions and the group factors. And this model actually gave these results. You can see them here in the ANOVA table. Both emotions and group were significant predictors of basic emotions. The interaction did not give anything, so we rerun this without the interaction, and still the emotions and the group remain significant predictors. And actually, as you see in the interaction diagram, sadder participants among all emotions, sadness is the one that characterizes the group continuum. So participants who were in this group appear to be significantly sadder, and that was the key result when it comes to basic emotions. Then we looked into the off-diagonal elements, the mixed emotions in our method, running again a linear model, but this time we used, instead of the diagonal elements, all the combinations of the sad emotion with the remaining emotions. Sad plus neutral, plus afraid, plus angry, and so forth. And here what we found was a trend that sadness with a bit of fear characterized actually the participants in the continual group, the frequently interrupted group. It was not significant, it was trending, and we believe, you see here the actual results, and we believe that this trend, it was at 0.08, is going to become significant, assuming that the number of subjects grows. Then, of course, the subjects had to take some psychometric questionnaires. That was our backup data, so to speak. The NASA TLX in particular was the questionnaire they took. The C group appeared generally overloaded, and specifically was mentally overloaded and effort-wise overloaded. That correlates with stress results reported earlier in the literature and explains, we theorize, the sadness result. The sadness with touch of fear, I think that's probably we predict comes from anticipation in the frequently interrupted groups about when the next interruption is going to hit. So to synopsize the results, the key result was that the frequently interrupted group, the C group, was significantly sadder with respect to the B group, which was mostly neutral. And in terms of mixed emotions, sadness mixed with fear was trending in the C group. Psychometrically speaking, these results were well supported because the C group appeared overloaded with respect to the batch group, and specifically was clearly mentally overloaded and effort-wise overloaded. And some examples of subjects from the batch group. So you see, for example, the coherence matrix for this subject, a batch group, neutrality reigns supreme. You see in this case there is a touch of angry feeling, and this feeling actually primarily is in the early part of the observation when they had to answer this long batch of emails, but then the rest of the time uninterrupted were devoted to the writing task. And you see that during this uninterrupted devotion to writing, the angry considerably recedes, and you see quite a bit of white. With an example of the continual group, you see a lot of blue that has to do with sadness, and you see that this sadness is distributed throughout the observational period as the emails were coming one after the other. And that's a key observation for the effect of multitasking. While the effect of batch is concentrated temporarily, the effect of multitasking is distributed. So this negative effect is distributed all over the place and it has a sustained character. We move into the discussion section. One of the key results in this paper is the method itself, this co-occurrence method, for accounting for not only basic but also mixed emotions. And because of the way of accounting, not only we bring an additional dimension, which is the mixed emotion dimension, but we size up in its correct dimensions the basic emotion aspect, which is overestimated in the previous methods. So in addition to the method, the results are quite interesting actually. We documented that frequent interruptions have a mental, see NASA TLX, and emotional cost, see the coherence matrix results, and basically sadness is an undisputable effect which is totally spread out throughout the timeline, and this is a sustained display of negative emotions. We fear that can undermine work culture, especially in open office environments, because there is a lot of documentation in the literature about emotional containment. Takeaway message: emotional cost of multitasking is a creeping effect. We do not even realize it, but based on the results of this study is there and is there continuously, and we fear that may play an undermining role in office culture. How can we fix this? In terms of human-computer interaction methods, we need to educate the users, need to be convinced to limit multitasking. We know it's difficult under modern office conditions, but with a little bit of organization, I think some progress can be done. For example, people can organize their day sending emails only 2 or 3 times and not continuously. This work has been supported by a collaborative National Science Foundation grant. Thank you.